Alright, so now moving into section 8.5, we're going to still deal with our radical expressions, but this time we're going to do multiplication and division. So starting with this problem here, what you need to keep in mind is that that squared term simply means that we've got this square root of 21 minus the square root of 5, multiplied by itself. Okay, so now we're going to do this multiplication. I like thinking of FOIL when I do these. And again, FOIL is first, outer, inner, last. So our first two terms are these. So I'm going to have the square root of 21 times the square root of 21. And then we're going to have outer, so it's this square root of 21. Oops, my line didn't draw very well. Times that negative square root of 5. So I've got minus 21 times 5. And then we've got inner, which is this square root of 5, times this square root of 21. So I've got another one of these. I'm going to write them in order just so that there's no confusion. Again, they're negative because we've got a negative here and a positive there, so that makes it negative. And then last, we've got this negative 5 times this negative 5. So two negatives make a positive, so we've got plus the square root of 5 times the square root of 5. Okay, so now when it comes to condensing these down, you can either write this out or just remember that when you have two square roots of the same number multiplied by each other, that simply equals that number without the square root. The reason for that is when, again, if you remember, we're kind of working backwards from what we were doing in 8.4. Instead of breaking things apart, if we put these back together under the same radical, we'd have the square root of 21 times 21, which is the same thing as the square root of 21 squared, right? Because we have a number times itself. And the square root of something squared is simply itself. Or you could just check this on your calculator to confirm it, but that's the mathematical reason for it. Okay, so this number becomes 21. This one right here, we're still going to have the square root of 21 times 5, which is 105. Same thing for this square root of 5 times 21 here. That's another 105. And then down here, we've got the square root of 5 times the square root of 5, which is just 5. Okay? Now, a lot of students I see try to combine these terms under the radicals together and get 0. You can't do that. You can only combine terms like this when they're multiplied or divided. If they're added and subtracted, you can't combine the numbers underneath the radicals. Okay, the best way to think of this, in my opinion, when you're dealing with addition and subtraction, is think of this as an x, this whole thing. So we've got an x here and another x here because these are the same number. Okay, so how would you combine a negative x minus a negative x? Well, that would be a negative 2x, right? Well, we're going to do the same thing. So we've still got our 21. This and this, instead of being a negative 2x, it's a negative 2 times the square root of 105. We have two negative 100, square root of negative 105. And then we still got our plus 5 out here. So now we can combine this positive 21 and that positive 5 to give us our 26 minus 2 with the square root of 105. Okay, so that's example 1. Let's move on to example 2. Alright, for this problem, we're going to rationalize the denominator. What that means is we're going to get that radical out of the denominator. Okay, and the way we do that is, again, we're going to go back to reference what we did on the last problem. If you remember, when we had the square root of 21 times the square root of 21, that gave us 21 without a radical. Okay, and when we rationalize the denominator, that means that we're removing the radical from the denominator. So the easiest way to do that is to multiply by that square root of 5 again, because that will give us 5 down here in the denominator. But again, remember, whatever you do to the bottom, you have to do to the top. Okay? So we're multiplying both the numerator and the denominator by the square root of 5. Okay, so that gives us 9 times the square root of 3 times the square root of 5 on top. and then the square root of 5 times the square root of 5 on bottom. Okay, so I'm going to start combining things together. So I've got 9 times the square root of 3 times 5 on top. And again, that square root of 5 times square root of 5 just gives us 5 in the denominator. Okay. So then we've got 9 times the square root of 3 times 5, which is 15, all over 5. Now the last step you would take in this is look at this number underneath this radical. Ask yourself if there are any perfect squares that factor into that number evenly, such as 4, 9, 16, and so on and so forth. Now, 4, 9, and 16, none of those are multiples of 15, so that 15 is as condensed as it's going to be. So this is our answer to this problem. All right, so I'm going to move on to the last example from this section. All right, so the last problem that I'm going to do from this section involves 2 terms in the denominator and how we handle that. Again, when we're simplifying these, we want to rationalize the denominator. We want the square roots to not be there any longer. So there are some problems from this section that I assigned that will illustrate the property that I'm about to use. But the way that we will get rid of both of these radicals in the denominator is we multiply by the opposite. By that I mean we're changing this sign in the middle to its opposite. So we're going to multiply the square root of 6 minus the square root of 5 on the bottom times the square root of 6 plus the square root of 5. And again, whatever we do to the bottom, we have to do to the top. Okay? So, if we multiply out the top first, I would have this square root of 2 times the square root of 6. I'll just write everything out for now so that there's no confusion. And then again, I'm using FOIL, first, outer, inner, last. So we've got a positive 2 times a positive 5, so I've got plus the square root of 2 times the square root of 5. And then inner, we've got a negative square root of 3 times the square root of 6. So that's going to be minus 3 and 6. And then we've got the square root of 3, a negative square root of 3 times a positive square root of 5. So we've got another minus root 3, root 5. Okay. So now we're going to do the same thing on the bottom. We've got the square root of 6 times the square root of 6, which, as you should know by now, that will give us 6 when we're done. And we've got the square root of 6 times a positive 5. So we've got plus root 6 times root 5. And then inner, we've got another root 6 times root 5, but this time it's negative. And then we've got a negative square root of 5 times positive square root of 5. That will give us negative square root of 5 times square root of 5. And again, this is the property that I'm trying to illustrate here. By multiplying this term by the opposites, these terms in the middle cancel. So all you'll be left with in the denominator are these terms that will become constants. I'm sorry, not constants, they will be constants that become whole numbers. Okay? So there are no longer going to be any radicals in the denominator, and that's the whole point. Okay, so now if we condense the numbers together on top, again, if we remember, any numbers that are multiplied together like this can be put under one radical. So we've got the square root of 2 times 6, which is 12, plus the square root of 2 times 5, which is 10. Oh, that doesn't look like a 10. That was a little more like a 10, all right. Minus the square root of 3 times 6, which is 18, minus the square root of 3 times 5, which is 15. And that's going to be all over 6, the square root of 6 times the square root of 6, which is just 6, and minus the square root of 5 times the square root of 5, which is 5. So as you can see, our denominator here is equal to 1. Therefore, our answer is really just the stuff in the numerator here. But the question now is, can anything in the numerator be broken down a little further? In other words, are there any perfect squares that divide into any of these numbers? So I'm going to give you a moment to think that over before I start. hopefully you've looked at this a little bit, and hopefully you recognize that two of these numbers actually have perfect squares that can be divided evenly into them. And those would be this 12 and this 18. So I'm going to break my 12 into 4 times 3. The 10 I'm leaving alone. And the 18 breaks into 9 times 2, and that 15 I have to leave alone. Okay, and again, I'm not writing it over 1 anymore because anything divided by 1 is itself. So I'm just working with the numerator at this point. So this becomes square root of 4 times the square root of 3 plus the square root of 10 minus the square root of 9 times the square root of 2 minus the square root of 15. Again, this simplifies down to 2 root 3 plus root 10 minus 3 root 2 minus square root of 15. Now, I know it seems rather strange, but this is as simplified as this problem gets. Again, because unless these numbers underneath the radicals all match, you cannot combine them. They are not like terms. So again, that's as simplified as this problem can get. And that's the last problem I'm doing from this section. So please let me know if you have any questions.